Okay, let's dive right into this explainer and look at a wild case study that shatters a very common and honestly pretty dangerous tech illusion. Welcome to our deep dive on architecting resilience. Today, we're bridging the gap between simply being in the cloud and actually making sure your app stays up when things inevitably hit the fan. Because, as you'll see in just a second, merely moving your code to a major cloud provider, yeah, it doesn't magically wrap it in some indestructible force field. 4. Now that number represents 4 incredibly stressful, agonizing hours. So, picture this. You've got a solid engineering team. They've written perfect code, they have a pristine setup, and then, bam, suddenly they get hit with a complete blackout. Their entire production app, literally the lifeblood of their business, is completely unreachable for almost 4 hours. No warnings, no error logs pointing to a bad deployment, just totally dark. So that brings us to part 1, the 4-hour cloud outage. To really understand how this nightmare played out, let's look at this real-world mid-sized company running their production app on AWS. When their app just vanished, they obviously assumed someone broke something, right? So they ran through the immediate panic checklist. Code, checked it, perfectly fine. Recent deployments, nothing unusual there. They looked at the database, humming along beautifully. Literally every single internal check, every dashboard they had control over, came back totally green. These were highly competent people. There was absolutely nothing sloppy about their architecture. Yet, they were completely offline. And the punchline to our little detective story? Well, AWS had a power issue in a single data center. Yup, that's it. One building had a bad day. I know, it almost sounds too simple to be true, right? But that was the root cause. One single physical building somewhere out in the world lost power, and it caused massive, crippling downtime for this entire company. Which leads us perfectly into part 2, the cloud illusion. We use terms like the cloud so often that it kind of paints this picture of a nebulous, invincible mist just floating up in the sky. It sounds like it's totally immune to earthly problems like a tripped circuit breaker or a busted transformer. But here's the illusion. Being in the cloud gave this team absolutely zero protection. Why? Well, because every single one of their servers sat in one single data center. They had a fatal flaw right in their setup. And it totally exposed the myth that the cloud is just magically invincible by default. At the end of the day, the cloud is really just someone else's physical computer sitting in a physical building. And guess what? Physical buildings can and definitely will lose power. Let's get into the mechanics of this in part 3, regions versus availability zones. Let's step away from the myth and into the technical reality for a second. We're going to demystify some of those terms that engineers always memorize just to pass a cloud cert exam, but then immediately forget the why behind. It is absolutely crucial to understand the physical difference between these two concepts. On one side, we have a region. Think of this as a broad geographic area. For example, US East 1, which is located in Northern Virginia. On the other side, you have an availability zone, or an AZ. These are the physically separate data centers located within that broader region. It's kind of like the difference between saying, hey, I live in New York State, versus I live in this specific apartment building in Manhattan. So an availability zone is really just a separate data center built so that if one has a bad day, the others don't even notice. Let's completely strip away the technical jargon here. An AZ is not some magical digital entity. It's a physical building. It's got walls, it's got floors, it's got heavy server racks. And because it's a physical building, it can, and sometimes does, suffer from physical failures. We're talking fires, floods, or you guessed it, power outages. But here's what makes AZs truly awesome and truly independent. Inside an isolated AZ, you've got its own independent power supply. It has its own dedicated cooling system, its own separate network connection. They share absolutely zero critical physical infrastructure with the other AZs in that same region. That means if a backhoe accidentally cuts the power line to AZ number 1, AZ number 2 just keeps right on running, completely unaware of the drama happening just a few miles down the road.
3 to 6. That happens to be the number of availability zones that most AWS regions have. Now, cloud providers don't just build 3 to 6 massive data centers in a single region for decoration, right? Or just to brag. That right there is your actual safety net. But, and this is a big but, it is only a safety net if you actually choose to use it. Our company from the case study? Yeah, they had every single server sitting in just one of those zones. So when that one specific zone went dark, their entire operation went right down with it. Let's talk about how to prevent that in part 4, the simple fix.
Look, putting all your digital eggs in one physical basket, exactly like our example company did, is a huge vulnerability. But the leap from being incredibly vulnerable to highly resilient is actually surprisingly easy. You seriously do not need a PhD in computer science to fix this. Step 1, just spread your servers across at least 2 availability zones within the same region. Simply don't put everything in one building. Step 2, let a load balancer route your incoming traffic. Think of a load balancer as a really smart traffic cop. If it sees that AZ number 1 is having a power failure and acting all sluggish, it instantly stops sending users there and routes all the traffic right over to your servers in the healthy AZ number 2. Boom, you've just survived a major data center outage, and your users didn't even notice a blip. Now I know what you're thinking. What if the unthinkable happens and a whole geographic region goes offline? Like, say, a massive natural disaster hits Northern Virginia. Well, for bigger outages affecting an entire region, you take it a level further. You duplicate your entire setup across a second region entirely. So maybe you're running in Virginia, but you also keep a copy running over in Ohio. That's definitely the next level of resilience. But honestly, for most everyday outages, just using multiple AZs is your golden ticket.
Which brings us to our final takeaway. Part 5, Building for Failure.
When you sign up for a cloud platform, whether that's AWS, Google, or Microsoft, they're really only giving you the pieces of the puzzle. They hand you the raw materials, but not default resilience. It requires checking your own setup instead of just assuming the cloud provider handles it all for you. And honestly, this is the gap that gets people. It's that comforting assumption that someone else is taking care of the hard stuff. But nobody builds resilience into your account by default. You have to actively choose to use multiple AZs. You have to actively configure those load balancers. Ultimately, it is your job, and your job alone, to architect your systems with the absolute expectation that physical hardware will eventually fail. So I want to leave you with this pretty provocative question. If this one data center went dark right now, would your users notice? I want you to take a hard look at your own architecture. Do you know exactly where your servers are physically sitting? If you can't answer that with 100% absolute certainty, I challenge you to spend just 20 minutes today digging into your setup. Go look at your cloud console. Because at the end of the day, if you aren't building for failure, you are quite literally building to fail. Thanks so much for joining me on this explainer. Go check your systems, and I'll catch you on the next one.